rotten child. What'd you do today?
TurboTax for an hour.
I drifted last night.
What do you mean you TurboTax for an hour? Doing your taxes?
I did a fictional person's taxes.
Oh, I was like,
It was so dumb, I hated it.
what, TurboTax?
Yes, TurboTax.
TurboTax is easy though.
It took me an hour, and I didn't even finish the assignment.
Okay, I will say on TurboTax, I usually have to ask somebody, what do they mean by this? Some things on there. But otherwise, TurboTax has been nice. If you, because they say, hey, did you buy a car this year? Nope. But if it's somebody else's, because you already know your stuff. Because somebody else's, yeah.
I don't like TurboTax. I don't like taxes.
Well, you got to file them and you got to.
No. I think I'll just skip that.
I actually, where's my pens? Over here. I actually, the past few years, have paid someone to do my taxes, only because my mom had passed away and she had all this paperwork stuff, and I'm like, I don't even want to deal with that. So I just pay someone, and I'm going to pay someone again this year because there's some other form, but this is the last form, and then I don't have to worry about it. So I was like, I don't even know what this form is. I don't want to deal with it. So I just pay someone to.
Okay, cool.
Next year, TurboTax. I'll go back to it. Yeah, it kind of happens that way. So I was like, that's too much paperwork stuff. I don't want to deal with it. So, okay. So yesterday you guys did this, and basically it was a kind of take you back to first trimester a little bit when we're talking about rigid transformation. So remember, a rigid transformation was just a reflection, it was a translation, it was a rotation. It did not change the size, shape, or whatever of your figure. It just moved it, spun it around. A mirror reflection. You guys think a mirror, but that's about all you kind of were talking about yesterday. So it's kind of bringing back some of that vocabulary. So that's what it means by a rigid transformation, is that it doesn't change anything about the shape, just the location of where it's at on your paper. So, because we've talked about a different transformation, we've talked about a dilation. Well, a dilation kept it, a triangle, but just made something bigger or smaller. If something was so times as big or times as small as something. So on this one, I kind of wanted you guys, work on these together so you could kind of remember some of that stuff. So how far is A from B? Well, we did that the other day, and you should have got 5, correct? Because you changed it into a nice little right triangle, and we've done A squared plus B squared equals C squared stuff, correct? Yes?
Yep.
You either did or you didn't. Okay. All right. So then it says transformation. What would take if you were, you can kind of look at that as I was driving to B. I live at A. I'm driving to B. How would I get there? And you're not taking your car through buildings. So basically, it's like you take it down streets. So you could have said something like, I'm going to go down 3 blocks and then to the right 4 blocks. I'm going down 3 to the right. You could say I'm going to the right 4 and then down 3. That'll get you there. You can take this route here, or you can go across and take that route. Kind of depends. Maybe there's construction on this route, so you take a different one. So an easy way to look at that was just look at, well, how many left, right, up, or down did you do? So it didn't really say. So then another way they said was, where's my paper? Where's my paper? There's my paper. You could say just this. I went -3, 5. I started there and I went to There, that's giving me directions on how to get somewhere. Okay, Stephen, what's going on? Are you gonna make it?
Yeah. My eye hurts, but I'm gonna make it.
Okay.
I know.
Ooh,
Migraine. I could go.
the Rona. Better watch out. Okay. I think most of you, I'll just put up what I had. There's my really crappy drawings right there. So the first one was about a rotation. So you want to rotate 90 degrees. So what you had to do is if you're going 90 degrees, it's, let's say I'm moving. Okay, I'll get in a little closer here. If I'm moving this line 90 degrees, and then you have to decide, clockwise, counterclockwise. Clockwise goes this way, counterclockwise moves it that way. But I'm going here. So basically, it needs to make a 90 degree with what point you're moving it from. So I was moving it from right here. So it's like if I just stuck my pen right there and then just push this around, that's a rotation. Think of like fan blades. Okay, you see one, and then you just move it around, and then eventually comes back here. But on that, so this old line and this new line should make a 90. So this point and this point, they all should make a 90 in there. If I go from this corner point down to there, it makes a 90 degree angle in there. Okay, so that's all that does. If I'm moving this point, ended up over here, it makes a 90. There's my center, and then there it's at. So another way I told you guys, because some of you guys do this, and then you're like, I think I did it wrong. And I said, well, if it's 90 degrees, you see how my point is facing kind of this way, my trapezoid. Well, if you pick up your paper and move this 90 degrees, yeah, it should look like that. That point should be pointing in that direction. Your kind of trapezoid, your parallel sides should be facing that direction. So if you look at it right here, whoops, okay, it is. If I pick this paper up and move it 90 degrees, which would just be a quarter turn of your paper, then that's what you get. Okay, and then the next thing said to just translate it, right? Move it over, move it down, something like that. It said go from here. So what you could look at is if you're not sure, this is just telling you a direction. So by you telling me, well, I just go to the right one and then down 4, this is the same thing. And I don't have to say 2, 0, 3, negative 4. I could have said something like 5, 7 to, what would that be? I could have gave you those directions. But what all that is going to tell you, if I'm going from here to here, is, okay, so if I went from 5 to 6, I went 1 to the right. And if I went from 7 to 3, okay, I went down 4. Because remember, your first one is your left, right, and your second one is up, down. So these are really irrelevant when you're talking about, I'm just trying to give you directions. But when I say, well, where's that go? This is what you guys kind of think of. Oh, I go the right one and then down 4. So move everything to the right one and down 4. And that's what you got there. Okay. This one was the same type of thing, but you were going counterclockwise. So you were moving it this way, 90 degrees. So this was my one, because that was a reflection, right? Is that what it said? Yep. Reflected across the y-axis and then rotate it. So like I said, if you pick up your paper and rotate it, that point, those parallel sides will be right there. Well, yep. When I rotated it, there's that point and my parallel sides are there. So if you just move it a quarter turn, that's 90 degrees. Okay, so the last one was just show me that these are congruent. So you could count the 3 and the 2, and then the other one was the square root of 13, which is about 3.6. And then the measures of the angles, well, if you're going to use a little SOHCAHTOA, one of them's around 34, one of them was 90, and the other one was around 56-ish if you round. So all the sides and angles were the same. Okay, so I'm going to this here. It says because triangles are congruent, there must be a sequence of rigid motion that takes one to the other. So how could I move triangle ABC so it lands on triangle DEF? What could you do? What could you do? How would I move this so it lands right there? Somebody tell me.
By using one transformation or
You can use however many you need to.
you could translate it.
It said a sequence of them. Translate it how?
You could translate it so that B lines up with E. So move it over, and then you could rotate it so it lines up. I don't know exactly how many degrees, but
Well, and the degrees to me is kind of irrelevant with some of this. You know, if you can just tell me, you know, well, if I went, you know, down one back and put A on here and then just rotated that, but just tell me clockwise, counterclockwise until it meets. I mean, sometimes it's obvious that, hey, it's 90 degrees, and it's obvious, but sometimes it's not, it's 60 degrees, but I don't expect you to know that. So any of these points, you can kind of move them over to their matching one. If you took B all the way to E, well, then now you have this triangle up here. Well, then just rotate it counterclockwise until A matches up with D. So it doesn't have to be something fancy. It's just something, how do I get from there to there? Okay, so I'm not telling you how you have to do this. You know, you could rotate it, you know, from A until it kind of stands up. So B's, and then just shift it over and shift it down. It doesn't really matter. Just tell me how to get there. But a sequence of them is, okay, several of them. Okay, so now let's look at the homework because I didn't really give you too much with that. I just kind of said, do this. All right, so with this one right here, I just said do 1, 2, 3, and 4, correct?
Yeah.
Yes. Okay, so number 1 said reflect triangle ABC over the line x equal -3. So where is the line x equal -3? Ouch. Like a dog. Huh.
It's on -3x.
So if I go on the x-axis to -3, that dark line I just put in there, that's x equal -3. So if you need to make a little note, so if you've screwed this up, no one asked me about that one. If you have x equal to any number, it doesn't really matter what number I put in there. And if you need to write these notes on there, write these notes. If you have y equal to some number, that's a horizontal line. Okay? And I know it's kind of the opposite of what you're thinking because you know where the x-axis is. But if I said x equal -3, that means every single point on that line, their first coordinate is -3 and some number. So this is your x equal -3. So if I said reflected over that, you're used to saying, hey, reflected over that y-axis. Hey, reflected over the x-axis. That's easy. Those are right there. But if I do something like that, okay, that's a little bit different. Okay, so if you right now skip that because you weren't sure what x equal -3 was, that's fine. I'll let you guys kind of finish this out. I'll tell you what your final coordinates should be for those of you that maybe think you did it correctly. So once you did everything, it says, okay, what's your final image? So you reflected this and then you translated it. These should be your final location. Okay. So if you need to kind of finish this one out, you can finish this one out. You don't just draw that and then say, oh yeah, those are my points. Because if I put that on a test, that's not really going to help you out. So I'll kind of leave that one. And while we're working today, if you have a question about it, I'll come find you. So if actually you'll raise your hand and ask me, I'll come find you. All right. With this one here, so if you want to jot down these points and make sure.
Would they be negative?
No. These right here?
Yeah.
No. So just get those down if you're not sure, because you still had to do one more thing with that because it said now to translate it. So I'll just save that for a hot second. So if you want to write these down, I haven't finished it out. All right. So number 2, what happens if you rotate that 180 degrees?
The same.
Yep. Okay. So if you flip this around and it said by that midpoint and you flip it all around, you'll see an N. I mean, my letters would be a little bit different, but the shape itself would still be this. And if you're not sure, you just flip it 180 and hey, that looks like what I started with. So. All right. So if you need to finish that one, finish that one. With this one, you started off with this triangle and then they did this. How can I put that one onto that one? What'd you do? How'd you move it? How? Like that way, that way, that way, that way, that way.
Rotating.
Oh, is that way? Okay. It's just that way. Oh, I got it. I mean, an easy way, you could take B to that B prime and then reflect it over the x-axis. That's what you did? Why didn't you tell me that?
You want to make it as difficult as possible.
It's not nice. You could have right here reflected it over the x-axis and then moved it B to B. It's not the only way to get there, but it's just one way to get there. That's kind of the easiest way. Number 4, prove triangle ABC is congruent to triangle DEF. How do you know those two triangles are the same? I mean, it already tells you they're congruent, so you know they're the same. How do you know?
Fold.
I didn't tell you, they told you.
Yeah.
Prove it.
Well, if you do a series of vertical transformations, they'll align.
They will align? Yeah. See, I didn't even do that. I just did their lengths. And I did a little, figured out all 3 sides of one, matched all 3 sides of the other. We're good.
Good job.
They've only done-
That's just what I did. So, like on this one, obviously ED is 2 and AB is 2 because they're vertical and a horizontal line. So that matched up. And then I just kind of turned these diagonals into little right triangles here. So this one was 5 and that one was 5. And the other one was the square root of 17, which was 4 point something. Steven, you're a weirdo.
I'm sorry, he did it first.
I saw you. The second kid always gets caught.
hate that rule.
It's always the same thing though. It's like you throw something at him, and then I look up and you throw. I'm like, stop throwing things. And you're like, well, he threw it first. Happens. Second kid always gets caught.
Keep going.
I'm just telling you.
What about the third kid? Third kid.
By then, no one cares about the third kid. Third kid's just like, we have
The
3 now.
moral of the story is always be the first one to throw the punch.
Yeah.
Yes.
That's what I was thinking.
Yes.
That is what-
Second kid gets
that's what
caught.
I'm thinking. That's why I don't like this school.
Telling you, that's how it works. Yeah, third kid, they're just like, man, we have 3. I can't keep track of
It's
3.
like, if you get punched and you act in self-defense, you're gonna be seen punching the kid, and then you're the bad guy
Yep.
Right.
for defending yourself.
I know.
And then you say, no, they punched me. And then the kid who punched you is even like, yeah, I walked up to him and punched him. And you're still the one who gets in trouble.
Yeah.
And then
Because they
start
said
punching
you
the
do it.
teachers, and then
The teacher punches you.
and then you take it outside.
Oh.
and you fall on the snow, and you get snow on your boots, and you're so mad.
Oh.
Yeah, soggy socks.
Boy, this really took a turn. Yeah. Huh. Okay.
Socks are-
I never got in the fight because I'm a good kid.
Oh. Oh my. Okay. I'm moving on.
I know how to box. I'll fight you.
Oh gosh. This is recording. We don't need people knowing this. Okay, I'm gonna be done there. Oh.